So we talked about perfect squares, and we're going to talk about perfect cubes. In math, you're expected to be familiar with squares and cubes. After that, anything to the fourth power, fifth power, those are we don't use those as much. But we do like to be comfortable with perfect cubes. And I'll be honest with you, the perfect cubes that are really the most common are 1 times 1, 2 times 2, 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3. The one thing that students often forget, because we know that the first perfect cube is 1, and the second one is 8, because 2 times 2 times 2 is 8, and the third one is 27. But before I go on with this list, I have to bring out the fact that not only is it a positive, but we could talk about negatives. Because if I have -1 times -1 times -1, or -2 times -2 times -2, or -3 times -3 times -3. Now, why does that work out that way with cubes? Well, because if we go back to our perfect squares, and if I have -2 times -2, or +2 times +2, the answer is always going to be a +4. But if I take the negatives and I cube them, I will get a negative answer. So these numbers come from the negative side of the number line. Okay? So +4 cubed and -4 cubed are +64 and -64. +5 cubed and -5 cubed are 125. Positive and negative. You notice I only need to write the number, but I can write the plus and minus. This is two numbers written as one with that little symbol there. And so if you've got your calculator, now that's +6 cubed and -6 cubed. +7 cubed and -7 cubed. Okay? So you kind of get where these are going. And I'm running out of room. Well, let's do 2 more. We'll just do up to 10. 10. So +9, -9. 729. +10 and -10. 1000. Okay? So those are perfect cubes. So if you're taking the cubed root, now you notice that the index number has changed. This means that I have to have 3 of the exact same factors being multiplied in order to bring one of those factors out. And 8 happens to be 2 times 2 times 2. It's an exchange rate. I have to have 3 of them in order to bring them out from underneath the radical. Okay? It's an exchange rate. So I go over here and I see that that's 10,987. So this is 5. Now that 5 is just hanging out there, and he's waiting to be multiplied by whatever we bring out from underneath the radical sign. And you have to have that 3 there. You cannot leave that unwritten. This is equal to 7 times 7 times 7. So since I have 3 of the same factors, I can bring one of them out. So this is going to be 5 times 7, which is 35. It's an exchange rate. 3 sevens underneath the cubed root is worth 1 7 outside of the cubed root. Okay, now over here we have a negative, and if this were a square root, that would be a problem. But since we know we can get negative numbers by multiplying negative an odd number of times, okay, I look up here and I see that 27 is -3 times -3 times -3. So that means I can bring one of those factors out. Okay? the cubed root of negative 1,000 is going to be a negative 10. All right. So these practice problems are going to go much the same way as the others. If we don't have perfect cubed roots, same thing as with non-perfect squared. We're looking for one of these factors up here as a factor of the number that's underneath the cubed root. So I'm looking at 40, and well, 1 will go into it, but that doesn't really get me very far. Will 8 go into 40? It sure will. So this would be the cubed root of 8 times the cubed root of 5, because 8 times 5 is 40. Now, I know that I can take the cubed root of 8 because it's 2 times 2 times 2. So this is going to be 2 times. Now I can't take the cubed root of 5 because there are no numbers that if I multiply them together 5 times, or I'm sorry, 3 times, that they equal 5. All right? Factoring is going to be a big part of this. Okay, so I'm looking at 192, and I'm going to look at the numbers that are smaller than 192. It doesn't do me any good to consider these big numbers up here. But 192 happens to be 64 times 3. And I can take the cubed root of 64 because that's 1, 2, 3, 4 times 4 times 4. That's why it's good to have this list handy. So the cubed root of 64 is 4. Now, I don't have any numbers to come out of that 3, so they got to stay there. Simplifying. This is what we're doing here. Okay, I want to come down here to the negatives so that I can get those in before I gotta end this video. This is negative 2, and pulling it apart will really help you to concentrate on what you have to simplify. So now 250, I'm thinking about those 5s. Doesn't do me any good, this 1,000 number up here, but this 125 here. So I've got that negative 2 over there. So this is the cubed root of, and I can put the negative 125 here. That leaves a positive 2 there because they have to multiply to be a negative number. Now, I've got to put the negative with the 125 because it'll simplify it by bringing that negative out. Does that make sense? I could leave the negative over here with the 2 and bring a positive 125, but then we're going to have negatives, and it's just easier to get the negatives out when we can so that we can simplify. So this is going to be negative 2 times, this has to be negative 5, times the cubed root of 2, which would be 10 cube roots of 2. You see how much niftier, how much neater that answer is than if I had left the negative in there and a negative out here? I hadn't simplified it all the way. Okay? So I will upload these notes so that you guys have them. I was going to jot down one more here. This is going to be the cubed root of, let's see, 96. Take the negative with the cubed if you can. Cubed root of 12. So this will be 8 times, let's see, that's going to be a negative 2. And I know you're sitting there looking at that 12 and going, last time we could simplify the 12. But we have to have 3 factors, and 12 is 3 times 2 times 2. I would need another factor of 2 in order to bring anything out. Okay, so if you've got any questions, let me know. And your assignment today is going to be these problems here. There's 18 of them, but hopefully they'll go real quick. So I'll catch you guys later. Have a great day. Get out and enjoy some sunshine.